the results of the midterm too. So basically, I would say the results, I mean, statistically, the result is pretty much similar to the midterm one, because the midterm one, the mean is around 14.5-ish. And the only difference is the Q1 is a little bit lower than the midterm one, but the other statistics seems to be pretty close. And for the distribution, again, it's very, very left skewed. But what is surprising for me is that I didn't realize that there's like a bimodal in the histogram of this distribution. I studied a little bit like uh, what introduced this kind of bimodal shape. So I look at whether is it because of the different course code. Like some of the student is from one level course and some of the students from the two level course. But it turns out that that is not the reason. So what I guess, or what I estimate, that it could be like some of the students, they have less workload in the 1 week before the reading week, and some of the students, they have a lot of things to do, so I guess they don't have much time to prepare for it. So I guess that could be the reason to tell this kind of difference. And very interestingly, remember I asked a question about how do you feel about the difficulties of the midterm two, and I pulled out the survey, and um, I summarize them into this count table, which is the main topic we are going to go over for today. So I specifically compare like the students from different classes, and it seems that the students from the two level are more likely to agree that the midterm two is easy, because like we have like one student answering strong agree, while the mode for this distribution is around neutral, while for the one level, like the mode is on the disagree. That's a very interesting result. And but of course, don't be afraid when you realize that the midterm two is difficult. So when I feel that, okay, I think this midterm, the score does not really affect your understanding, or I would say that the distribution is too weird, I will curve the scores to a uh, wheel-shaped distribution after all of the final assessment. So don't be afraid of the difficulties of these courses. And ideally, I would like to keep the modes around the neutral, because I don't want it to be too easy or too hard for you guys. So yeah. Okay, so today we are going to play a lot with this table, because this table is present a two piece of the variable. The first variable is the class code, and another variable is how strongly you agree with the midterm two is easy or not. So we have two different variables, and both of them are either categorical or either nominal or ordinal. So we're going to we'll play with it a lot. Okay. uh, so today we're going to study the relationship between the categorical variables. And just again, to put this piece of the lecture into your knowledge structure. So today we are still heading to this inference statistical part. So, in a previous lecture, we studied like how to draw conclusions about the relationships between these quantitative variables. And today, because we already talked about quantitative variables, so we definitely need to talk about it another type, right? So logically, today, here is where we are. We are going to talk about the categorical variable. And but at the beginning of the lecture, for a disclaimer, that I would say today is we do involve a lot about mathematical derivation in this lecture, and I have to admit that for most of the derivation we're going to go over today, we do require you to know how to calculate the results. So I hope that you can have it will be best for you to have a calculator prepared, and you can use either your computer or any like a physical calculator to participate in the class. So first of all, just a quick review. Like the last lecture, we kind of reintroduced the idea of what is the quantitative variable. And we know that quantitative variable is the variable that is measured in forms of numbers. So the difference of the quantitative variable and the continuous variable is in the whether we can quantify the ordinal data into different numbers. And uh, so for ordinal, we consider it to be discrete. But for those ordinal data, if we can, after we quantify it into numbers, because right now it is numbers, so that satisfy our criteria for the quantitative variable. So what about categorical variable? So so logically, because the categorical variables are the variables that's the counterpart of the quantitative variable, right? So which means they are the variables that cannot be, or they are not being measured through the forms of numbers. So in that case, we usually say the categorical variables is defined as the value that is measured in forms of the labels, like how how agree you with midterm two is easy and something like that. So which is not present into in form of the numbers. So that's the pretty much the variable we are talking about for today. So today we are going to jump back to the example we used a lot. So in the lecture 5, in the study design, we talk about how to design a study to study the association between the weather and the different moods of the cat, right? So for this example, because both the explanatory variable, which is the weather, and our outcome, which is the moods of the cat, both of them are categorical, right? Because both of them are nominal data. So this is a very nice example for studying the relationship of the categorical variables. So the most important tools that we are going to use in the study of the categorical variables, that is the two-way tables. So you actually already seen in the lecture 5. So here I'm just going to quickly review what we have learned in lecture 5. So what's our example is like we want to study what's the association between the children's moods and the weather of the corresponding day, right? So we have two variables, and we want to study the relationship between these two variables. And the characteristic is that both of them are summarized uh, in forms of the categorical variable. And this example is actually even more special because both of our variables uh, only have two categories, right? So the moods is either happy or sad, and the weather is either sunny or rainy. So both of them only have two categories, which is the most special cases in the study of the categorical data. So what we did is, first of all, we need to summarize all of those data in forms of this 2 by 2 table. What we did is, like, we take a snapshot of our data set, and then we just count, like, how many counts in each of the combinations. Because we have 2 by 2 table, we have two in the weather and two categories in the moods. So in total, we have 2 times 2, which is 4 different combinations, right? So then we just trying to find how many times those combinations appeared in our data set. So in this way, we will summarize all of this, 1 0 information into these counts. So this 2 by 2 table is the most basic table we're going to use through the whole lecture. Okay. So this is pretty much we learned in the lecture 5. And I would say this 2 by 2 table provides us a lot of information. And the most straightforward information, which is called the marginal distribution. So the marginal distribution is corresponding to the case where we're only interested in one single variable. So uh, here it is defined as where you are only interested in one of these random variables. So for example, say we're only interested in like what's the marginal distribution for withers, and we don't really care about the moods of the cat. And in that case, what we did is we collapse uh, each 2 cells in the same type of the weather together. So by that means, we're only looking through this direction. So the first element will be given by the sum of, of these 2 cells because we don't care about the moods right now. And likewise, for the raining days, we just count the total number of the counts in the raining days. So this marginal distribution will be given by the row sum. And for this row sum, you can see that we cannot tell any kind of information about our second variable, which is the mood in this case. Similarly, sometimes we just care about moods. We don't want to look at what's the distribution of the weather. And in the same way, we will collapse our 2 by 2 table according to the different moods. So we have the first cell equals to 10 plus 2, and the second cell is corresponding to 2 plus 4. So we collapse them together. And here you find out that again we get 12 and 6, and also the previous one is also 12 and 6. But remember, this although the number of these two distribution is the same, but they completely represent different things. So here these numbers are the same just by coincidence. So as you can see, after summarizing the marginal, summarizing these 2 by 2 tables in the forms of the marginal distribution, we do have lots of the information, right? So like if we are from the marginal distribution of the moods, we don't know, we cannot tell anything about the weather. And for the marginal distribution of the weather, and we kind of lose the information of the moods. And even if we have the both marginal distribution, say we have both the a marginal distribution about the moods and the marginal distribution about the weather, but we cannot use those two marginal distribution to help us to decide whether two variables are associated or not. So which means we cannot study relationship from this marginal distribution. Then people might ask, then why do we do marginal distribution? What's the point of do that since we lose our information? So the point for the marginal distribution is more like it to understand the big picture of our data set. Because sometimes when we get a data set, we have a lot of, we have a lot of variables. And at the beginning, we don't know like how to play with the different variables because there are so many options, right? So the best thing is to first to explore it one by one. So that's where that's the place where the marginal distribution coming about. So okay, so let's try an exercise. So let's come back to the table that you have already seen in the first slides, where we are studying the relationship, the class codes, and the different level of the agree with the difficulties of midterm 2. So then tell me, what's the marginal distribution of the students' feeling about midterm 2 in this table? Okay, just using the knowledge we just learned in the previous 2 slides. So when we calculate the marginal distribution, we will collapse, right? We will collapse the corresponding cells. Okay, Okay, so let's go over those answers one by one. So let's look at the question. So the question is about what is the marginal distribution of the student's feeling. So what we're looking at is the student's feeling, which means we are looking at this variable, right? So in this case, when we're trying to compute the marginal distribution, we should collapse our tables according to these variables. So, okay, then we start to collapse it. So the first one is basically 0 plus 1, which is 1, and second one is 10 plus 15, which is 25. So if you compute them all, you will finally realize that, okay, C is the correct answer. So the problem with the B is that B is actually the marginal distribution for the another variable, which is the class code. And the problem with A is that A is incomplete. So usually when we talk about the marginal distribution, we need to display the complete distribution. We cannot just ignore some of the levels. That's not correct. And the problem of the D is that D is not a marginal one because we didn't take the sum. We didn't collapse the cells. So the correct answer is C. Okay, I think you guys did a pretty good job on this question. And here, I would like to emphasize that there's a very important thing. So when we talk about the distribution, we are not just talking about the numbers. So if I asking you like what's the distribution of something, then you just put like 125, 64, 51, or something like that. That's not complete because for a distribution, we need to include both the numbers and also their corresponding labels. Otherwise, we don't know what these numbers represent, right? So that is not the distribution about. So remember, to describe a distribution, we do need to include both variables, both values as well as the labels of the categories. So that's a very important comment. Okay, so after discuss the marginal distribution, then we can introduce the most important concepts for today, which is the two-way table. And two-way table is a more like it's frequently used by non-statisticians. And for statisticians, we more frequently use the word the contingency table. So basically, contingency table refers to the combinations of our original 2 by 2 table, as well as their two different marginal distribution. And additionally, we're going to includes the total sum, which is given by the sum of all of the elements in our 2 by 2 tables. So in fact, these two-way tables has a very nice property. So if we look at our original 2 by 2 table part, we can see that the sum of it is 18, right? And if you look at the two cells on the right-hand side, the sum of it is also 18. And what about this one? The sum of it is, again, is still 18. So which means we can divide these two-way tables into 4 different regions. So for each region, the sum will be the same, which will be the same as our total sum. So that is a very nice property for this two-way table. And here I would like to emphasize that although the two-way table contains the word two, right? But here, try to distinguish the difference of the two-way table and the 2 by 2 table. So 2 by 2 table is just the first region where we talk about the comparison of the two different elements. But two-way table is contain more information. It also contains the marginal distribution as well as the total sum. So we cannot say 2 by 2 table is two-way table. Okay, and in fact, two-way table, we could have even other dimension. We don't have to be 2 by 2 table. For example, in this table, dimension is actually 2 by 5, right? So So I would not say 2 by 2 table is a special case or has any relationship with this two-way table. So just trying to tell the difference between these two concepts. Okay, so after talking about the two-way table, then we're going to do another exercise. So right now we have this table, and so just trying to compute what's the value in this cell. So basically, this two-way table has several information missing, and whether can you try to recover what should be the value in this cell X. So you probably need your calculator to compute that. So remember, the two-way table has a very nice property that the 4 different regions has the exactly same sum, right? So we do need to use that piece of the information to help us to calculate that. Okay, I already see you guys did a very good job. So in fact, for this question, we can do it in 2 ways. So for example, we can start from this row sum. So for this empty cell, because this region should be sum up to 147, so which means these cells should be given by 72. And after knowing this row sum, we can use this information to compute the missing x, which is 72 minus all of these elements in the other cells, right? Because this is because uh, this is the sum of all of these values, right? And we can do it in another way. We can do it in this way. So we first fill in this empty value. So this one will be given by 147 minus all of this known values, which is given by 41. And then 41 is the column sum of this, the column sum of this category, right? So finally, x will be our column sum minus this known value. So this property for the two-way table is really good in a sense that we can use it to check whether we make mistakes in our two-way tables or not. For example, we can see that whether there is some like a mismatching in the results, such that some of the region is not sum much to our total sum. So that is a very nice way for us to check our two-way table. Yeah, I think you guys did a very good job. So after talk about the two-way table, then so far we only talk about like for the marginal distribution, we only focus on one single variable, right? So now let's look at one step further, in which case we are going to look at the both variable simultaneously. So when we're trying to take the another variable account, in that case, we usually introduce the so-called the conditional distribution. So conditional distribution is basically the distribution of one variable holding the value of the another variable fixed. So for example, if when we study the distribution of the moods, we are specifically only interested in the weather when it is a sunny day. So in that case, we can see that for that distribution, we have a condition, right? The condition is that we only look at the sunny day. So in that case, the conditional distribution will be only given by this row. So which is the 10 and 2. And again, because conditional distribution is a distribution, so always remember, put both the labels and the numbers together. So similarly, sometimes we are interested in the the conditional distribution of the moods when it is the raining days, and in that case, we will looking at the second row, which is given by this 2 and 4. And again, don't forget to put the labels into when we're describing the conditional distribution. So the idea of the conditional distribution is that we want to look at some specific case in another variable. So as you can see right now, although this conditional distribution of the moods is still the distribution of the moods, but now we are taking another variable account. So it's not just a single player games. Okay, so it has another variable coming to play. And but still, this conditional distribution of the moods it is the distribution for one variable, right? So since it is a distribution, we can use some other ways to express this distribution. For example, we can use the what we learned in lecture 3, where we use the bar chart to display the distribution for categorical variable. And similarly, we can use the pictogram, dot plot, or pie chart to display this piece of the information. But the problem for this conditional distribution is that right now we only focus on the categorical variable. So in that case, we cannot use the histogram or box plots to display this conditional distribution because the histogram and box plot are for the quantitative variables and not for the categorical variable. Okay, any questions so far about the conditional distribution? Okay, if there's no question, let's do another exercise. So for this exercise, the question is, what is the conditional distribution of the students' feeling about the midterm two, given that the students is a student are in the group of S2037? Okay, let's see the result. Okay, I think we have a quite diverse result. So let's go over which each option one by one. So definitely B is not correct, right? Because right now we are talking about the conditional distribution of the student's feeling. So every time when you see a question like this, first of all, you need to figure out what is the condition and then what is the variable we are trying to study. So in this question, the variable we're trying to study is the student's feeling, right? So which means we are studying this variable. And what we are condition is specifically this variable, this category. So we're only looking at this category. So that's why we are looking at this direction. So in that case, let me see. A is incorrect because A is a marginal distribution, right? So I guess the difference is in the C and D. So the difference here is that D include the sum. So when we talk about the distribution, do we include the sum into our distribution? So the answer is actually no. Remember, like when we draw the histogram or when we draw the bar chart, do we specifically put another bar, which is the sum of all of the bars before? No, right? Because the point of doing distribution is to look at how our data is or how our variables is distributed in different region. So that's the point of the distribution. So when we talk about distribution, we never take the sum into account. So that's why in this example, the answer should be C rather than D, because we shouldn't include the sum into our distribution. Okay, so right now we are talking about this problem, then we're going to change the wording of the question. So what about if we say the question is, we are studying the conditional distribution of the student's class for the students who agree the exam was easy. What about this? So again, when we're trying to figure out the conditional distribution, first of all, look at what variable we are studying. And secondly, what is the condition we are talking about? So first of all, trying to take two pieces of information from the question. Oops. Okay, so yeah, I think almost all of you get it correct. So the answer is B, because first of all, the condition is that the students who agree the exam was easy. So which means we're specifically only looking at this category. And the variable that we are interested in is the student's class. So which means we are looking at the distribution of this variable. So that's why we just put it, we just take these two cells out of this two-way table, and that is the answer. Okay, so far, any question about the conditional distribution? So I would like to highlight that for now, we only talk about the the discrete data, or I should say the categorical data. So that's why our distribution can be summarized by table. And for the quantitative variables, we still have conditional distribution. But for that conditional distribution, we didn't display in this table formulation. And of course, we are not covering that for this course, but you just need to keep in mind that the conditional distribution is not just for categorical variable. It can this concept is also exists in the quantitative variable. Okay, I think we went through very smoothly in the first half of the lecture. So I'll take a 10 minutes break. And if you have any question about the course, about the midterms, and or any other concern, just type in the chat, and I will went over all of the questions after the break. Okay. So right now is we went very quickly. So right now it's 2:05. So we will get back at 2:15. So during the break, I actually would like to um, play a music. Oops. And I'll tell you why I play this for you guys. Oh, the internet is bad. Okay, I'll answer all of the question after the break. Okay, I have stopped it here. So let's get continue. So I noticed that there's a couple of questions about some specific question in the midterm too. So how about I go over this question at the end of the course so that in case some student don't want to hear it, so they can just go. So I'll answer a couple of questions about some administrative question like uh, uh, will I review the midterm exam? So I will not go through the specific question one by one during the class, but if you have any question, you can just put it on the forum, and TA and I will help to answer that. And I have question about um, uh, what's the percentage for the final curving. So for this course, the history is that this course has had the average around 70%, but my expectation is like a 75 to 80% of this of the average. And when will the assignment two to be released? So. My TA told me that she would like have more time to grading the second assignment because there's a lot of a lot of wording and paragraph there. So she asked for more time. So I'll probably release the results of the assignment two this Friday. And in case you have some concern about like you would like to remarking, you can do it during the weekend or before the next Tuesday. That will be good. And okay, I have a question about today's lecture. So um, explain about the two-way tables and the two-by-two tables, right? Okay, so the difference for these two is that the two-by-two table is just the first component or the first region. So remember, we divide our two-way tables in the four different regions, right? So for this example, you can safely say that two-way table is your two-by-two table, add the marginal distributions as well as the total sum. So you can see that for this example, two-by-two table is contained in a two-way table, but that's just for this example. For another example, uh, like our distribution of the filling of the midterm two. This one you cannot say is a two-by-two table, right? Because the dimension is not two in our variable of the student's filling of the difficulty, right? Because the dimension of this is 5 dimension. So that's the difference for that. Okay, so if there's no any other question, I'll continue with the second half of the today's lecture. So just now I played the music, and the special thing for that music is that this music is composed not I would say it's composed by computers itself. So so nowadays, like we have such kind of um, concepts called AI, which is the artificial intelligence, which you might heard it a lot of times. So actually, the AI is closely related to our lecture for today. So, like for example, for the music that I played just now. Uh, so for example, sometimes what they did is that they trying to study what's the association between the people's reaction to the music as well as like what's the melody, what's the beats, what's the rhythm of the music, and then they figure out those kind of association or correlation, and then based on that they will do prediction. So, okay, so if I would like to achieve such kind of happy mood of the people's reaction, then can I predict what is the optimal rhythm or optimal beats could be appeared in my music. So in that case, we can just apply what we learned for today. Like we study the association first, and then we do the prediction. So of course, I oversimplify the process of the composing this music by AI, but it is pretty much very similar idea like that. Okay, so I have another question. So, oh, it's just about the previous question, the follow-up question for the previous one. So, um, so yes, so this one, this one is a two-way table. So two-way means two variables. It's not say variables with two categories. That's what I'm trying to emphasize. So like in the Cheetos example, both variables has two categories, right? Like the sunny, rainy, and happy, sad. Both of them has two categories, and that's two by two tables. And that is also two-way if we're adding the marginal distribution and the total sum. And this one we say is a two by five table because the categories is five, right? It's not just two. So so we can say this is two-way table, but we cannot say this is a two by two table. Firstly, because we add the sum, the row sum, column sum, and total sum. And secondly, the dimension of one variable is not just two. So just to clarify that. So far, we use our two-way tables to display the uh, two different angles of from two different variables. Then how can we tell what's the relationship between them? And can we use some like a mathematical form or some numbers to present such kind of relationship? So the answer is yes. And the tool that we're going to use is exactly what I'm presenting right now, which is the risks as well as the odds. So the idea of the risk is actually a little bit different from what we're talking about in everyday life. So in the everyday life, we usually consider risk as something negative and as something we're trying to avoid. But in statistics, the risk is just something like a very objective, and it could be something very neutral. It's not bad, it's not good, it's just something over there. So we are not highlight some emotional part of this value. So for example, in statistics, risk could be like the proportion of the times of an event happened in a group. And it can also represent the percentage of the group for which it happens. So the difference of these two is that the first one is talking about the same object, and we are observing it over and over again. And the second definition is that we have a lot of objects, we have a lot of units, and we just uh, compute what's the percentage of them have such some kind of characteristics. For example, for the first one, we could define the risk as the among the sunny days, the proportion of the days when Cheeto is happy. So, which means this is the risk for Cheetos being happy in a sunny day. And in the second definition, it could be like the percentage of the cats in a general cat population to be happy when it is a sunny day. So this is also interpreted as the risk of being happy for cats. And sometimes risk can be even something we haven't observed yet. It could be something we want to estimate or we want to predict. So in that case, it could represent the probability of something happened in the population. For example, we can define the risk of Cheetos being happy as the probability of Cheeto to be happy when it will be sunny tomorrow. Because for tomorrow, we didn't observe it yet, but we can kind of get a sense of what's the probability for the Cheetos to be happy. So mathematically, the risk is defined as the number of the occurrence in the group divided by the total size of the group. So it might be a little bit abstract for you. So let's go through some examples. So for example, in this 2x2 or in these two-way tables, like we describe the relationship between the weather and different moods of the cat, we can look at different things. So first of all, we can just look at the risk of happy. So in that case, well, because right now we just talk about happy in general, and we don't specifically looking at a sunny day or raining day. And in that case, the risk will be the number of the days that the cat was happy divided by the total. So which is given by this total sum, and which is this 0.66667. And sometimes we would like to specifically looking at the days when it is sunny. And in that case, we can also define the risk of happy when it is sunny as the count of the cats to be happy in that day and divided by the sum of that. So the important thing here is that always remember to check the condition first. So like the first one, we don't have any condition. We just look at the risk of being happy in general. So in that case, what we are looking at is the marginal distribution. So from marginal distribution, we compute what's the percentage of such kind of categories in the total distribution. And likewise, for the second example, like the risk of happy when it is sunny. And in this case, we do have a condition, which is we condition on the scenario where we have a sunny day. So which means we are going to look at this conditional distribution. And just using the same definition, the risk is given by the counts divided by the total sum, right? So that's why from this conditional distribution, which is 10 and 2, it will be given by this formulation. So that's how this calculation coming about. Any questions so far for the calculating of the risk or the idea of the general idea of the risk? Any question about this? So basically, right now, this risk of happy or the risk of happy when it is sunny, so this risk contains a lot of information. So like it could be just like the example we present just now, like how many days, what's the percentage of the days that we observed that the Cheeto would be happy. And another interpretation could be like, say tomorrow, tomorrow, what's the probability for the Cheeto to be happy? So that's another interpretation because this is something not observable for us, but we would like to kind of estimate. Okay, if there's no question, so let's try an exercise. So what is the risk of strongly agreeing with midterm 2 is easy statement? So far, I think the difficulty for this question is that we have a lot of categories, right? So remember when we're talking about risk, we're only looking at the one category. And also, the first thing you need to do is to check whether there is a condition or not. Okay. I would like to give you more time, just help you to like. Okay, so first, is there any condition mentioned in this question? Actually, no. So there's no condition. Like here, we just care about the general case, like what's the student's feeling in general. We are not saying like we're only looking at a specific group of the students. So that's why in this case, we don't have any condition over here. So what that means, if we don't have condition, then we just look at the marginal distribution, right? So the marginal distribution is given by the column sum over here. And then what we care is just about the strongly agreeing this group. So which means we are talking about this cell. So that's why the answer is C, because we are comparing the percentage of this one among all of the counts in this. So which is should be 1 divided by the row sum of this marginal distribution is 147. So far, we define the risk to describe the kind of measure of a single random variable, right? And then we're going to look at the case where we have two random variables simultaneously. So in that case, we would define the relative risk. So the relative risk is actually defined as the ratio of the risks of the events by comparing the risks of the events that happened in different groups. So, for example, in the Cheetos example, we can when we say we look at the risk of happy, so we're not just look at happy itself. We are also kind of comparing this how Cheeto is being happy among the different weather. So in that case, our group will be our another variable, which is the type of the weather that involved in the study. And usually, the group A is something that we are interested in, and group B will be our control group. So, like in our say like a case control study, we usually regard the group B, take the group B as our control group, and group A will be our case group. And in our experimental design, our group A could be our treatment, and group B could be our placebo group or the control group. So for group B, we have another name to call it, which is the baseline, because that is the group that we are putting as our baseline. And then we are kind of looking at another group that we are interested in to compare with our original baseline. So that's the idea that why we call the group B as the baseline. So the interpretation of this relative risk is very important. So it is interpreted as the relative risk of an event for group A, which is the group of interest, and comparing to the group B, which is the our control group. So I guess from actually the interpretation of this relative risk is not too bad, but the difficulty part is if I give you some statement from this, can you know like how to construct the relative risk according to the statement? So that's a little bit tricky because the wording kind of twisted with each other, and the wording itself does matters in creating this relative risk. So to sum up, to analyze the statement, you only need to look at two different pieces of the information. The first piece of the information is what group are we comparing about? So in this case, if we're comparing about group A versus group B, then our numerator is something about group A, and the denominator is something about the group B. So this gives us a kind of a general presentation about what is on our top, what's on our bottom. So this is this information telling us this. And after doing that, then we will ask another question. What is the event we are interested in? So this event that we're interested in will help us to calculate the specific cell in each part. So this will decide like what is the event that we are trying to look at. So for example, say we are trying to study the relative risk of being happy for Cheeto on a sunny day comparing to a rainy day. So just for a first glance, there's so many things that appear in this statement, which is quite messy. So just keep in mind, first of all, trying to find the comparison, what we are comparing about. So here we're comparing like something about sunny day and to something about raining day, right? So which means the relative risk should be also given by something about sunny divided by something about raining. And then we're going to look at each cell specifically. So what is the event over here? So the event is being happy for Chido. So which means we're only looking at this event. So this is our event. So after knowing the event, we can determine each element of in our equation one by one. So first of all, we look at our numerator, which is sunny, right? So since our event is happy, so the numerator will be given by the risk of being happy when it is sunny, right? So this is calculated by, so for this one, again, we first look at the condition. The condition is when it is sunny. So which means we're looking at this conditional distribution, condition on sunny. So we're looking at this direction, right? And then we're talking about the risk of being happy. So we are calculating the percentage of our event in our conditional distribution. So that's how our the first risk coming about. And for the second one, likewise, we are calculating the risk of happy when it is raining, which means we are comparing the second conditional distribution, and the risk is given by the percentage of our event in our distribution. So finally, just plug in these two different risks in our relative risk over here, and then we can calculate, okay, our relative risk over here is 2.5. So the interpretation for this relative risk is like that. So so say what I'm interested in is what's the probability of for Cheeto to be happy, and if I switch, because you know our baseline here is our raining day, right? So raining is our baseline. So if I switch our weather from raining to sunny, then we have 2.5 times the probability that we will observe the cat will be happy. So that's what this relative risk telling us. So we are kind of telling us what's the how many times the likelihood for the cat Cheeto to be happy comparing to our baseline group. Does that make sense, right? Yeah. So any questions so far? I know it's kind of messing for this kind of statement. So there's a question about why we call this is baseline. So I hope you can understand the reason we call it baseline in this example, because like for the interpretation for the relative risk, the interpretation of it is just like what's the risk of our event for our group A comparing to our group B, right? So baseline is we call it baseline because it is something that we are comparing to. Like we are switching, if we're switching from the raining weather to the sunny weather, what's the change we would observe? So baseline is something that we base from there, and then we're looking after the change from switching our baseline. So that's why we call it baseline over here. Any questions so far? Okay, if there's no any question, then let's take an exercise about this. So what is the relative risk of being in SS 1023 for students agreeing with the statement versus the students disagreeing with the statement? So for this one, again, the first thing you have to do is to look at what is the comparison that will determine what's on your numerator and what's on the denominator, right? And after that, for each component, look after the event. What's the event we care about? I'll give you more time to think about this question. Okay. Oh, we kind of have a very diverse response. So first of all, let's look at what's the comparison. So here, what we're trying to compare is the students agreeing with the statement versus the student disagreeing with the statement. So which means we are comparing from this variable, right? Um, so which means the numerator should look at the conditional distribution of the first row, and our denominator is look after the condition of the second row. And what's the event? Event is oh, sorry, my bad. So the condition, the comparison is the agreeing with the statement versus the student disagreeing with the statement. So our comparison should be this column with this column, right? So that's the comparison we are trying to making. So in that case, the numerator should be the conditional distribution of this, and the denominator should be conditional distribution of this. And the event right now should be being in the one level courses. So that means the event will be our first row, right? So that's why the numerator should be 10 divided by the sum, which is 25, and the denominator is 30 divided by 51. So the answer is actually A rather than B, because like here well so after determining like what's on our numerator and the denominator, we are looking for the risk, right? And when you're looking for the risk, you need to find what is the condition you are conditioned about. So in the first statement, in the numerator, the condition is the student agreeing with the statement, right? So this is the condition. So that's why we're looking this conditional distribution. So the question is, are we only looking at SS 1023? Yes, we only looking at 1023. So 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 let me think about how to explain this. So you know the numerator and denominator is depends on what is our comparison about, right? And the event itself will determine what is inside each element. So if you look at each element, the first one is what we are looking at. We are looking at the student in SS 1023 in the agree group, right? And for the denominator, we are looking at still the SS 1023 in the disagree group. So in this case, we're just looking at SS 1023, not we're not talking about 2037 yet. Does that make sense? Yeah, I would like to give you more time to go to get clear about this. So basically, remember the whole process is a two-step procedure. First, we look at what is the comparison, which will determine what are the two conditional distribution we're going to play with in the next step. And in the second step, we look for what is our event. And then we compute the event in the both 11 elements separately. Okay, so let's get continued. Um, so right now, uh, what we're trying to do in the relative risk is trying to do the comparison of two different risks, right? And here we are compare the student agreeing with the statement versus the student disagreeing with the statement. And when it comes to the comparison, the taking the ratio is not the single ways to do the comparison, right? And another way to do the comparison is just to take the difference. So that's why there's another idea coming about, um, which is the absolute risk reduction. And for this absolute risk reduction, uh, you can just understand it like the risk difference. So instead of taking the ratio of our group A versus group B, we are taking the difference from group B to group A. So because our group B is our baseline, it's something we start with. So that's why we put our group B first and then minus our group A. And we're looking at what's the difference of it by changing the group B into group A. So that's the idea for this absolute risk reduction. So the calculation is pretty much similar to what we have in the relative risk. So the only difference is the formula over here. So first of all, we still need to tell like what's the comparison in our statement. So our comparison is still the sunny versus raining day, right? So in that case, because our raining day is our baseline, so we put it in the first term, and the sunny will be our second term. And then after putting the structure, we're going deep into the detail for each element, right? And so the first one, the raining, because we're looking at the raining, which is given by this conditional distribution, and our event is the risk of happy. So we we compute uh, we compute this two over the total sum of this. So in this case, the risk difference will be given by the risk of condition on the rainy minus the risk of happy condition on the sunny. So that's uh, that's how we calculate the risk difference. So the idea is pretty much similar like in the relative risk, but it's just the structure of in our comparison is different. That's the only difference. And can you go back to the last slide and explain, please? You mean this slide? So the take-home message for this slide is that uh, comparing by taking the ratio, which is the relative risk, is not the single way to do the comparison of two different risks. So here we use another way to do the comparison, which is just to take the difference. And because remember, group B is our baseline group, which means we kind of start from group B. So that's why we put it in our first term and minus group A. So the interpretation of this risk difference will be like after switching our group to group B. Oh, sorry, after switching group B to group A, what's the change of the risks of our events? So that's the interpretation for this ARR. How, a very good question. So there's a question about how do you know which group is the baseline group? So this is coming from our study design. So which is coming from our lecture 5. So for example, in the cross-section study or in the survey study, in that study we kind of we can we can we can study from either direction. Remember, because for the survey study, we don't have a requirement. We have to compare from each kind of direction. But for the cohort study is like we start from our exposure, and then we observe our outcome, right? So in that case, uh, our outcome will be our event, and our cohort study, our explanatory variable will be our comparison. So in that case, our study designer will determine which one will be our control group. So for example, in the study of the smoking versus non-smoker, and in that case, we could consider our non-smoker to be our control group, and we trying to look at what is the increase of the risks if these people start to smoke. So that's the idea of the determine the baseline, and that is also, I hope that also helps to explain what's the interpretation from this definition. Yeah, very good question for this one. Yeah, any other question? Oh, okay, there's another question like could you quickly go over the calculating relative risk example with the cat again? So I guess the question is about this. So the first part, right? So the relative risk here, I say is sunny versus raining. So for this one, it is only determined by what is the group you are trying to compare, right? Here we just compare the sunny day versus the raining day. So that's why the numerator is sunny and denominator is raining. Yeah, so this part, we just look at what we're trying to compare. So besides the absolute risk reduction, there's another way to measure what's the difference between the risks of the two different groups. And there's another concept called the relative risk reduction, which is also known as the increased risk. So the basic idea is that the numerator is coming from our previous slides, which is the absolute difference divided by the risk of the event of our baseline. So this quantity tells us, instead of looking at what's the absolute difference, we're looking at what's the relative difference, like what's the percentage of the change of the risk will happen if we switching from group B to group A. So that's the interpretation for this relative risk reduction. So again, the computation here, the only change will appear in the formulation over here, which is the comparison part. So since we are still comparing sunny versus rainy, and our rainy is our baseline, so our formulation should be something like this. And the other part is exactly the same. So the computation of the risk of each single element is the same as we did in the relative risk. So we just plug in those values into this formulation and we times 100%. So the big question for this one is, what's the interpretation for this RRR? So basically it represents that, because our baseline is the raining day, right? So if we're switching from rainy day to sunny day, what's the percentage of the change that would happen in the risk of being happy for Chilo? So that's the interpretation for this one. So right now we have negative 150, which means if we change from rainy if we change from the rainy to the sunny, and the risk will minus 150%. Okay, so okay, okay, I guess you guys have a lot of question on this one. So basically, the tricky part for this one is that the RRR refers to the difference because it is the baseline minus our interest group, right? And divided by our baseline. So we're talking about what's the change in the percentage. So here, the change of the percentage will be 150%. And also here is a negative, so which means the risk will be decreased. So here, because based on our calculation, right, it's 0.3033 minus our 0.833. So this difference is kind of, oh, sorry, I think it should be increased rather than decreased because the number is actually increased from 333 to 833. So so the minus here should be increase the risk rather than decrease the risk. Because we put the baseline at first over in this formulation. So the interpretation should, sorry, I think I just made a mistake. So the interpretation should be, if we switching the weather from rainy to sunny, then the risk will increase 150%. So the negative sign here is not decreasing, but increasing because we are using the rainy minus sunny. And you can also tell it from the numbers, right? Because if you're switching from the rainy to the sunny, the value or the digits will increase. So if it is raining, you reduce the probability of happiness by 150%. Yes, if it is raining, but here, because raining is our baseline, right? So what it is a baseline means that we are comparing start from it. So we usually start from raining and switch the raining to sunny. If we want to do it the other way around, we should switch the raining and sunny in this case. So our denominator should be sunny and the numerator should be sunny minus raining. And in that case, the interpretation will be after switching the from sunny to rainy, what's the change of our relative? What's the change of the risk? Because yeah, my mistakes because the definition of this one is the relative risk reduction. So we are talking about the reduction. So which means we have a negative reduction means we have increase. So yeah, it's kind of kind of ambiguous over here. So we have a negative 100% is actually an increase 150% of the risk. Does that make sense to you guys? Yes. So if this is a positive, which means our risk reduction is positive, and in that case, which means our risk is actually reduced. Is which means the risk is decreasing. Any other question? I just want to make sure you guys are clear with this concepts. Yeah, so because the RRR is defined as the reduction, so that's why the interpretation of this negative sign is a little bit different from our intuition, which is kind of a tricky over here. Okay, So if there's no other question, let's try an exercise. So what about the relative risk reduction of being in the SS 1023 for the students agreeing with the statement versus the student disagreeing with the statement? So again, trying to look at what is our comparison and first determine what is our baseline group. Yeah, I'll give you more time to think about this. Does anyone want to volunteer to try to explain this one?
I can do it.
Okay, yeah, just to try. Using the logic we mentioned just now.
So I think it's B because, pardon?
Yeah, continue.
Oh, sorry. Okay. So I think it's B because if you look at the formula for relative risk reduction, it's risk of B, and in B in this case would be the disagreeing group. So it would be 30 over 51, and then you minus risk A, which is 10 over 25 in the agree group. And then
Yeah.
The difference, you take the difference and you divide it by group B.
Yeah,
And
that's correct. Yeah, very good. Yeah, that's awesome. Yeah, that's correct. So the answer is B. So I think her logic flow is very clear, right? So first, we know that our baseline is the student disagree, so which is that will determine what's on our denominator, and because our event is spin in SS 1023, so we're looking at 30 over the sum. So that's why this is this one. And we take the difference from our baseline to our, our interest group, which is agreeing with the statement. So which is 10 over 25 over here. So the answer is B. Okay, great. I'm glad that you understand that very well. Okay, so far we use like a percentage or probability or proportion of times these measures to describe into a single measure, which is the risk. And sometimes I don't know why they can't come up with another idea, but there's another way to describe such kind of relationship. So there's another type of the measure to describe the what's the percentage or the distribution, but it's not like the percentage, but just like the comparison within the group. So there's a concept called odds, which is defined as the comparison between the numbers of the units of the event versus the number of the units which is not appear in the event. So for example, say if our event is weather right now, okay. So while we are comparing, so say our event is sunny day in the weather. So in that case, the comparison is not just like what's the percentage of the sunny days when cat is happy, but on the other hand, we will directly compare our event versus the non-event. So in the risk, we calculated by 10 over 12, right? So that's the percentage. But now we do the direct comparison. So the direct comparison will be 10 divided by only 2. So that's the difference. So the points of doing odds. So actually for odds, it is frequently appear in gambling because in gambling people don't like risk. They don't like the word risk, and they like the word odds because it's kind of like something opportunity or something like that. And also, I guess they prefer odds than the risk because risk is a percentage, right? But odds is a ratio between our two groups directly. So usually, the number of the odds could be extremely large, right? Because for percentage, it cannot exceed one, right? Because it's a percentage. But odds, it could be any positive number. So sometimes people would like odds in the gambling because that means they it looks like a more chance. So that's the idea of the odds coming about. Yes. So the question is in what is the odds for this case? So if we are looking at the events of the sunny weather, the odds for this conditional odds, condition on the cat is happy, it will be it will be 10 to 2. So usually when we describe odds, we can we can either use a numeric number or we will use 10 to 2. And we never say like 10 into. That's wrong, right? Because it's not a percentage. We cannot say 10 in something, but we usually say 10 to something. So that's the interpretation for odds in a sense of the wording. So similarly, for odds, we can also define our general odds as well as our conditional odds, right? So in general, means we'll only look at the marginal distribution. So say like what's the odds of being happy for Cheeto? Then we just look at the marginal distribution of being happy. The marginal distribution of the moods and look at what's the number of the times it is happy versus the number of the time it is not happy. So it's a direct comparison. So the only difference is in fact in the denominator over here. And similarly, we define the conditional odds for sunny days, which means we condition on this one, and we look for what's the percentage, what's the odds of the happy would be 10 to 2, and for the rainy days will be 2 to 4. So the structure here is exactly the same as the risk. It's just the comparison changed. Any questions so far? I guess if you understand the risk well, you should be understand odds pretty well because it's pretty much similar. It's just how we do the comparison. Oh, so we cannot, so in odds, we cannot say 10 to 2. Sorry, we cannot say 10 in 2, and we have to say 10 to 2. Or you can say the odds is 5 in this case. Only in the risk, you can say 10 in 12 because that makes sense because risk is about percentage. But odds is not a percentage. So we cannot say something in something. We have to say something to something. Yeah, so that's just something about the wording. Okay, so let's do another exercise. Hope you guys won't feel too much about this. I guess this one is quite straightforward, right? So first, look for condition. Is there a condition up here? If there's no condition, then we look for marginal distribution. If there is a condition, we look for the conditional distribution. Okay. So To answer this question, first we look at the condition. So there's no condition appeared in this question, right? Because we are not saying what's the odds of the student from SS2, like when they answer agree or when they answer disagree. So we don't kind of have this condition. So that's why we look for marginal distribution. So in that case, it will be very straightforward. The answer will be A, which is 72 to 75. And finally, I'm going to step into the most important concepts in this lecture. So previously, we defined the odds, which is trying to describe the comparison in one variable. And then we are going to, just like in the relative risk, we are going to look for how to describe this comparison simultaneously for two variables. So odds ratio is defined as the ratio of the odds for the event in the comparison between group A and group B. So similar to the relative risk, it is the ratio of the odds of group A versus the odds of the event for group B. And the things in the odds ratio is that it is not uh, straightforward in the interpretation like the relative risk, because the relative risk is like if we change from our group B to group A, what's the change of our risk? But for odds ratio, you can say like um, from change if we change from group B to group A, what's the change for the odds? But what does it mean for the change of the odds? Because this odds itself, if you describe the change, it is really weird because odds is about the rate is about the ratio of two things, right? It's something to something, and for example, 2 to 1 change to 3 to 2, and this, I mean, intuitively, this interpretation is not so clear to a general user. So what I'm trying to say is that the odds ratio is not suitable for the interpretation. But odds ratio has a very important role in this lecture. That is, it will help us to determine how strong the association for two random variable would be. So um, first of all, I would like to cover like how to calculate this odds ratio. So the idea of calculating the odds ratio is very similar to the calculating the relative risk. So first of all, we look for what is the comparison, right? So again, it's the sunny versus rainy day. So our numerator is the sunny day and denominator is the raining day. And then after getting the big structure, we look for what is the how to construct the specific element, right? And for the first element, it will be the it will be the sunny days. So the odds of the happy for sunny days will be depends on the first conditional distribution, and also of happy for rainy days will be depends on the second conditional distribution. So this is exactly same, or I would say similar to the relative risk. But the only thing is that right now we do the comparison in the ratio rather than the percentage. So finally, the odds ratio is computed by the ratio of the odds, right? So which is 5 divided by 0.5, which is given by 10 over here. Any question in the computing odds ratio? Okay, so if there is no question, and we are going to uh, get into a little bit more detail about the calculations of the odds ratio. So here, the odds ratio calculation has a, I would say, has a drawback that the odds ratio can only be computed by a 2 by 2 table, which means it is perfectly uh, fine for the case where we have two categories in one variable and two categories in another. like our Cheetos example. But for our students feeling about of the midterm 2 example, this is not so good because this is a 2 by 5 table. So we cannot directly calculate the odds ratio from this. So if that is the case, we have to do something to calculate that. So either we use some advanced statistical approach, which I'm not going to go through in this course, and to compute such kind of uh, uh, quasi odds ratio, which is the fake odds ratio, but not as defined as we mentioned just now. And another way is trying to dichotomize the contingency table. So dichotomize means we're going to group the variable which has more than 2 categories into 2 categories. So for example, so for this variable, it's okay because we only have 2 categories, either 1023 or 2037. But the problem is this one. So we have 5 different categories, right? So we are going to trying to dichotomize it. So first of all, for the neutral level is not linked to the either side, right? So in that case, we can just simply remove it because it does not tell us what's their preference or something like that. And then for the strongly agree and agree, we're going to merge these two columns uh, row wisely. And also for the disagree, we're also going to merge this column row wisely, which means we'll merge 30 and 4 together and merge 21 and 2 together. And in this way, we could end up with a 2 by 2 table. And since it's a 2 by 2 table right now, then we can go ahead with the calculation of the odds ratio, which will be given by this one. And another special case is that what if we have a 0 count in our table? And in that case, it will be problematic because if you computing the odds ratio, the 0 will be appeared in the denominator of our formulation, which is really bad because mathematically, the 0 cannot be appeared in our denominator because that's undefined, right? So the approach that we take is called HA correction, which means we're going to add a 0.5 to each of the cell. And in that case, our new 2 by 2 table will be given by this formulation. So in this case, we have 10.5 and our 0 now becomes 0.5. So we're going to calculate the odds ratio based on this corrected 2 by 2 table. And in this way, the odds ratio will be meaningful because we don't have a 0 in the denominator and we can use it to compute the odds ratio. So this is a very special case when we're computing the odds ratio. So the odds ratio part is very, very important. And it's so important that I put another topic for the odds ratio into our independent video, where we're going to talk about how we tell the association from the odds ratio itself. And there will be a post-video quiz coming after the video, which will be posted on this Thursday. And also assignment 3 is available right now. And so I think you should be able to work on all of the questions of the assignment 3 after watching the video. Actually, there's just one question related to the video. And for the remaining question, you already can answer that. So it's basically when it's basically goes through all of the the concepts that we covered in the previous lecture and today's lecture. So I prepared two very interesting data sets for you, and hopefully you will think that will be very helpful for you to understand those concepts. Yeah. So this is pretty much for today. And like before, you are good to leave for now. and I'll see you the next week. And I'll stay here for answering questions. So I remember there's a question about midterm. So I'll stop sharing right now.